Thank you very much for the invitation. Actually, I'm pretty excited to talk for first time on my first virtual wall event. So yeah, that's awesome. Actually, I have been running and jumping as probably you are doing right now. So yeah, today I'm going to introduce you into the IoT wall. I know that you are mobile developers, maybe web developers, or any kind of other developers. I have been 15 years on the wall of the IoT. But I'm also a web developer. I'm also a mobile developer. I have been doing some native and responsive applications in the past. But yeah, during this session, I would like to show you how to get started with the Internet of Things. I would like to show you tools and techniques that probably you are using currently on your daily base as a developer that are starting to be available for IoT developers. So actually, if you have been into the IoT, I hope that someone is IoT expert in the audience as well. Probably you will know that that tools on IoT and embedded wall are pretty old, IDEs, etc. So now what you are going to see is that these new tools like Docker containers, continuous integration, etc. It's something that we are trying to push into the Internet of Things. And with that, meanwhile, I'm showing that we are going to help researchers and scientists to crunch data to fight the COVID-19 coronavirus. So I think it's a good mix to help developers all around the world, or in Europe, Czech Republic, whatever, to get introduce them into the IoT, and of course help researchers and scientists to fight the coronavirus. So let's start. I have 3 screens, so maybe I'm looking on different places. Don't worry. Let me introduce very briefly myself. So I'm Marc. I'm developer advocate at Balena. I don't know if my screen works good or not. Let me check again. But yeah, this project I'm gonna share with you, it's working. Let me do again this, because I don't know why it's not refreshing properly. Let me start the presentation again. Okay, only see half screen. Let's do this. If it works like this, it should be okay. Okay. So actually, yeah, this project it's working right now. What I'm gonna show you, because my colleague David Tischler, who is as well a developer advocate at Balena, who actually is based in the US in Arizona and is sleeping right now probably. He has been working very hard to put all the pieces together to help researchers and scientists to fight this COVID-19 coronavirus. Okay, so now for me, it's important. If you have a Raspberry Pi at home, so give it to you. I give you some seconds. Bring it on your table next to your laptop or wherever you are, in the sofa, in the couch, wherever you are. Bring it with you, because I will show you step by step how to set up this Raspberry Pi with IoT techniques and help us to fight this coronavirus with some scientists. Okay, so. This would work with Raspberry Pi 3 plus B, I guess, with 64 bits, 1 GB of RAM, or Raspberry Pi 4, any kind of Raspberry Pi 4. So if you can bring that, or any kind of board that, it has Linux, that will work really good. I don't know if my screen works good or not. I'm sharing my screen. I don't know if I should... let me check. Sorry, because I don't see my screen very well on the presentation. Can you confirm on Slack, Vara, or someone if it's working well or not, please? Okay, so let me refresh. Sorry, this is if it's not working, I'm gonna do a B plan. That's not a problem. So let me refresh this. Yeah, it's first time in a virtual wall doing a demo, so it's shit happens, no problem. So let me try to restart my Firefox. Let's see if this works now. Okay.
Mark, maybe could you put your presentation on full screen in the browser?
Sure, let's try.
Try that, please.
I don't know why it's not working. Anyway, no problem. I can go. I have a B plan, so no worries. Okay.
Yeah, it didn't work,
So
but
can
yeah,
you
thank you.
see?
Sorry. Well, technical conference, it always happens.
Wait a sec. Let me try to share again my screen here. Sorry. How to restart this? Okay. Give me a sec. So I want to share this. Yes. Okay, let's try this. Okay. So first of all, let me show you. So I don't know who in the audience knows Balena. Okay, as I told you, I'm developer advocate at Balena. David as well. So probably, I don't know, just jump in case that you know what is Balena. Maybe you don't know Balena, but maybe you have been using Balena Etcher or Etcher to flash some SD cards. Actually, Etcher, it's one of our most popular product in that it's currently today being used for millions of people. Etcher is a software that enables developers to flash SD cards or USB pen drives, and you can flash their operating systems such as Linux or whatever, and flash computers or old computers, laptops, or boards, IoT boards like Raspberry Pi and similar. So if you have been using Etcher, you have been using one of our software, one of our products. So that's you have tried what we are trying to do. We are trying to reduce friction. This is why Etcher is very, very well used, because we are trying to reduce friction on developers. Okay. So on the other hand, on Balena, we have a really cool department that it's the hardware hackers. That actually what they do is they are all the day hacking projects and building cool projects on the top of Balena. So what's the goal of Balena? So at Balena, what we do is we help companies who are connecting tons of devices to the internet to just help them to manage the fleet of devices that are connected all around the world. So as you're going to see, managing one device, such as the Raspberry Pi, as I'm going to show you, it's pretty simple. But when you get into scale with thousands of devices all around the world, and you detect that there is a bug in the software that it's running one of the devices, so it's kind of tricky, to update the software. Probably it happens the same. If you are a mobile developer and you want to update the version of a mobile application that it's actually installed on millions of mobile phones or thousands or whatever. That's a tricky moment, right? To update the version and see how that people don't update the last version, so they can have issues, etc. And then the experience, it's problematic, right? So what we do is we simplify this process to the developers that that put devices connected devices into the wall. So we enable them to update the devices over the air with Docker containers. So no matter where you are, so you just, in one click, as I'm going to show you, as a developer, you are able to deploy to all your devices all around the world. Okay. All right. So this is what we do. I was actually explaining the hardware hackers. So actually, my colleague David is one of the most important parts of this story. Actually, when the coronavirus appeared on March, April 2020, depending on the countries. It was a big mess, right? And so as well, I'm based in Barcelona, so I found a lot of initiatives made by makers. So all of the makers of the city or the country just get together into Telegram chats or whatever, trying to put 3D printers together to print PPE material for people or for health system, doctors, nurses, etc. There were other people working on making ventilators. That's pretty amazing what they did with ventilators, at least here next to Barcelona or in Spain. But yeah, we didn't have any experience on 3D printing or ventilators. Actually, David was actually brainstorming very hard what he could do, he didn't have any 3D printer, or he didn't have any experience on 3D printing. He didn't know how to do ventilator, etc. So he decided to test software. So he was Googling for software, and he found one software called Folding at Home. Folding at Home, for people who don't know it, it's a software that makes distributed computing. What does it mean, distributed computing? So distributed computing means that you lend your CPU or your GPU from your computer to scientists for running simulations using your CPU power. So usually, with one computer, you cannot get much, but if there are millions of people all around the world, so that means millions of CPUs or GPUs, better or worse, that are computing these simulations. And sometimes they get better than a supercomputer that in a country or whatever. So actually, this distributed computing has been used. I don't know if you know this SETI at Home. SETI at Home is kind of an old software that actually, what the scientists are doing, they are getting the signals from outer space, and because the signals that they get from outer space are huge amount of data. What they do is they use distributed computing among millions of computers that they lend the idlet CPU of their computer to compute or to run simulations or run a specific software on the top of these signals to see if one of these signals comes from another planet or something like that. Okay, so that's the key of the Folding at Home. So actually, David in March, actually, he had one of his old laptops running Folding at Home. And he was saying, okay, actually, I can do that. That's pretty cool. I really like the philosophy behind. But as he's working at Balena, so we have like a bunch of devices on the table. It's pretty crazy, all the boards that we have, etc. So he was like, okay, why? So I have one laptop, but I have dozens of devices on my table. Why I cannot use these boards and connect them to Folding at Home? So he actually was trying to see if he could take part of this project, but he couldn't make it. But he get in contact with some peers from the community, and they found another project that it's called Rosetta at Home. Let me open the website. I think it's here. Yeah. So Rosetta at Home, it's similar than Folding at Home. It's actually a distributed computing software using this software called Boinc, Boinc, that actually it's the same that the SETI at Home actually. So with this software, we are helping scientists that are based on the Baker Lab at the University of Washington in Seattle to folding. You can find more scientific information here. So what they are doing is actually running simulations on CPUs to folding the proteins of the spike of the coronavirus. So actually, the coronavirus makes some spikes, and there are some scientists running some simulations to find the spike of the virus, so it cannot get into healthy cells. So for running these simulations, so they have tons of data, and they are using this distributed computing, these massive CPUs all around the world to run these simulations and to see what works and what it's not working actually. So then David met them and met some ARM people, and what he was trying to do was, okay, so this is running actually this Boinc for Rosetta at Home. It's working for x86 processors, but why we cannot make it run on ARM processors? It's like the processor that is on the Raspberry Pi. Okay. They met the people from the Baker Lab at the University of Washington, and they decided, so it's open source project. Why don't you try to port our code of x86 to ARM and to see if it works? So with the hardware hackers and some other people from the community, they made it. So they ported the code from x86 processors to ARM. And then they tested, they connected with a real data set, and they spent a couple of weeks testing that the data that was crunched with this ARM processors, with Raspberry Pi and similar devices, was correct, and that the people at the scientists at the Baker Lab could make sense of that data. Okay, so actually, having to account that this is not for vaccines or anything like that. It's just focused for treatments when you get the coronavirus, the COVID-19. Okay, so so that was a moment that the application was crunching data, and at Balena, with the Balena hardware hackers, we made it run for different devices, but and then what we did, it was to create a website. Okay, a website where we could enable people actually at all around the world to help us to fight the COVID-19, and probably like us, that they didn't have a 3D printer, or they didn't know how to do a ventilator, but they could bring a spare laptop or a Raspberry Pi or something like that to crunch data and to help researchers to fight the COVID-19. But actually, so as I explained before, so what we do at Balena, what we do is we have some Balena software that runs into a very tiny operating system running on these boards, and then we do containers with Docker, and on these containers it runs the business logic of your software. So as I told you, we try to reduce friction. So that means that it's pretty simple to connect a Raspberry Pi on Balena and, for example, run a Node.js code. So if you go to balena.io and you sign up, you will see all the step-by-step to do it. It's pretty simple. But actually, this project was more focused for people with no experience, no technical people, actually. So we were thinking a lot on, okay, how non-technical people that maybe has a spare computer at home or something like that can, take it and just plug it with our software in a really simple way. And this is what we tried with this website. On this process of as I told you before, so on the process of Balena, actually, what you need to do is to install different packages. We have what we call Balena CLI, but it's actually a kind of Git software. So you clone a Git repository that will you have the Docker template, etc., and then you push it into the Balena. And as I'm going to show you in some minutes, when it's into the Balena application, then it gets deployed in all the devices and all the fleet that it's into that. But actually, we wanted to simplify that. So what we did was a next step with the Balena hardware hackers here. And actually, it's this. So what we did is we precompiled the Docker containers inside an operating system image, the Balena operating system image, with the goal to enable anyone to download the operating system. So this is what I'm going to show you right now with my Raspberry Pi 4. Okay, I'm going to get into the Balena fall4covid.io website. Okay, and I'm going to follow step by step how to join the fall4covid army with Balena. Okay, you will see that it's pretty simple. As I told you at the beginning when the slides were getting cracked, if you have a Raspberry Pi, bring next to me with your Raspberry Pi and an SD card, okay, and some electricity, and I'm going to show you step by step how to power it up and join the fight for the fall4covid. So if you go to fall4covid.io, actually, you go to get started, and we created operating system images for all of these boards that are actually ARM or x86 IoT devices. Okay, another that is pretty famous is Nvidia Jetson Nano. For example, we have Raspberry Pis. There is a Google Coral. There are a lot of devices that are compatible with this. Or actually, you can bring your own laptop or desktop computer or your main computer, installing actually the Boeing But let's go to Raspberry Pi 4, okay? So first thing that needs to do before downloading the operating system, actually, it's to decide how I'm going to connect my Raspberry Pi 4 to the internet, okay? I'm going to connect it through the Ethernet or with Wi-Fi. So I wanted to connect it with Wi-Fi. So I think that's my Wi-Fi. Let me check that. Okay, not really. It's this. Okay, and here I have to put my password. Let me check. What is my password? Okay, so I just paste it here. Okay, so now what's gonna happen here is that I'm gonna download an operating system image. Yeah, downloading here below, so 148 megabytes. Downloading an operating system image that it has a Docker container with my Wi-Fi credentials pre-installed. So next step that we are going to do is to burn or to flash this operating system image into an SD card. As I told you, we have a product that is called Balena Etcher that it's very well used. So we are going to use Balena Etcher to burn, to flash my SD card with this operating system that I just have downloaded here. In case that you don't have Balena Etcher, just download it. It works on Mac, Linux, and Windows, okay? I actually have Balena Etcher, so I'm going to open it here. Okay, so actually I'm going to select the image that I downloaded here. So it's the Balena Cloud, Rosetta Home. I open this. I actually, yeah, it detects I have a 32 gig SD card here connected, and I'm going to flash it. I'm going to use password. Okay, so it starts flashing 1 minute. So what's happening here, actually, it's that we are flashing the SD card with the operating system. Once it's going to be flashed, it will be really simple. We will need to just get the SD card from my SD card reader and plug it into into the SD into the Raspberry Pi, and I'm gonna power it up later. Okay, with the cable here. Yeah, I have electricity. Okay. So what else? Okay, so this is actually, I hope that some of you are doing right this. I'm gonna check later on the Czech Republic or whatever. If you are not from Czech Republic, just let me know on the chat or just jump, or I don't know, what can you do on a virtual wall to let me know that you are where you are based, okay? I don't know if the flags are allowed or not. Okay, so now I think I'm just checking the screen, and I just realized that you didn't see my etcher. But anyway, yeah, I have the SD card. I just put the SD card on my Raspberry Pi. Sorry, I don't have a second camera. And I'm just gonna power this up, okay? So right now the Raspberry Pi, it's just powering it up. Some seconds from now, it's gonna handshake with my Wi-Fi, probably, to get connected. From now, so we did some magic as well on Balena. So actually, what it's as well doing this operating system with the fault for COVID, it's creating some DNS on your router at home. So you can access actually to an interface that it's running into a container called Gotti, G-O-T-T-Y, that it's running into a container to show what's happening on the Raspberry Pi. So actually, if it works, that sometimes it works, we create this DNS name as fault for COVID.local. Let's see if it works. If not, we will need to research on local IP address on my network. Okay, it seems that it's not working. Give me a sec, because sometimes first time it's a little bit slow on handshaking with the Wi-Fi. Give me a sec. Yeah, I'm sure that there will be a lot of funny things to solve on this my first virtual wall presentation. But yeah, we're gonna solve that. Okay, so what I'm gonna do, I'm on a Mac, so I'm gonna check what's connected on my network. So I'm not gonna go with config. What's here? Let me see the IP
If I may just
address
say,
of.
I just started a poll to see where people are from. So in the meantime,
Sure.
while you are waiting to install, people can reply on Slido where you are from, because we know that there are several hundred of people watching us. So please reply to our poll where you are from.
Yes, please. Okay, Czech Republic, Prague. Trying to find what the IP address of my Raspberry Pi. Let me check that I'm on the same Wi-Fi. Yes. Okay. All right, no problem. So, okay, so mostly, and yeah, mostly. So let me know as well in the chat. Let's change the poll. 3D wall, yeah, that would be nice to have a passport from the 3D wall. I don't know what in the airports if they open sometimes. At some point, what they would say, but it should be nice to have a 3D wall passport. So, any IoT expert actually on the audience? Just
I'm
use the
sure there are
same
many.
poll.
Oh yeah, so we have people from all around the world. That's great.
That's awesome. Congratulations.
Nice. Thank you, people.
Okay, I'm having some problems to see where is this located, but no rush. I don't know, the ARP it's not showing me anything interesting actually. But no problem. I'm gonna go to the second demo. So on the second demo, we are gonna see something. Okay. So I don't know if I mentioned that. Actually, what's very interesting from this project, actually 6,100 people actually it's running this, what I did right now, probably with more luck than me to see the interface on GoTeam. But anyway, I'm going to show you what's happening inside, okay? And to do it, actually, everything that that it's on this file for copy, it's open source, okay? So to see what's going on inside, actually, there is a GitHub repo where you can go. And yeah, on the GitHub demo, on the GitHub repo, sorry, there is an explanation, okay, of what's happening, how does it work. As I told you, so in the beginning, as well, through the GitHub repo, you could actually sign up an account on Balena Cloud, use all the Balena CLI tools that actually are pretty simple. It says you need to do Balena login and Balena push to an application, but we actually try to simplify that process, and we create this button that we call it deploy with Balena. What does it mean, deploy with Balena? Deploy with Balena, it's actually a button that you click. Of course, you need to have an account at Balena, but it creates what we call an application. An application, it's the space where you will release or deploy software through containers, and then all the devices that will belong to this application. And it's not needed to be the same devices. We call device types. So we have Raspberry Pis, and different Raspberry Pis belong to the same device type. So this release on an application actually will be deployed in all the devices that belong to that application. So actually, what we are doing here is we are creating an application called Rosetta Home. I'm going to call it mDev. Okay. And I have a Raspberry Pi 4. And actually, we are going to clone this repo. That is the repo that I was showing you before. So I'm going to click create and deploy. And let's see if I'm more lucky than before. And we are going to be able to see something. Okay, so this is like inside an application at Balena Cloud. And first thing that you need to do, actually, is to add a device. Okay, when you add a device, what does it mean? So we need to download. So we have to do the same, actually. And actually, what is really interesting is that because we are deploying with Balena button, this application is actually already releasing, building the release of the containers from the Rosetta Home. Okay, so it's automatically building this release, and when we will add one device to this application, this release it's going to be downloaded, as you're going to see on my device. So what I need to do right now is just to download the operating system, as I showed you before. But in this case, we are not going to download the operating system with the precompiled Docker containers, as I did here. We are going to download just the operating system, the Balena OS plain, and then when this device is going to be added on this application, the containers that are releasing right now, as you can see here on this circle, are going to be installed on the. So I'm going to try to use the same. So as we don't see anything on this Raspberry Pi, I'm going to try to use the same SD card. So okay, yeah, I'm going to download this. Give me a sec. Okay, so Balena Wi-Fi. One thing that maybe happened, actually, it's that I just maybe I missed something when I was writing my password or something like that. So let me try again. Okay, so let's download the operating system. Okay, downloading. Let me put the SD card on on the SD card reader, sorry. You see my cool shirt. All right. So actually, if you are doing any other kind of project, so there are here some getting started. So let me go through this. So actually, documentation at Balena, it's super awesome. So we have really great documentation. It's bad to say it from my own company, but actually that's the reality. So the step-by-step works really good. So if you want to get introduced into any other kind of project, go here, and it's super simple to add a new device. And then, yeah, we explain here how the CLI works, how to install it. And it's pretty cool because there are some unicorns, etc. So feel free to use it because it's pretty cool. Actually, Balena Cloud, it's free up to 10 devices. So you can have actually 10 boards, crunching data now with the default for COVID or doing whatever you want. So I think it's a great opportunity to get introduced into the IoT with continuous integration tools and Dockers, etc. So it's great. So actually, I was integrated. I learned about Docker, getting introduced here. So let me do this. You don't see anything. Just now mDev, selecting the SD card on Etcher. So right now I'm on Etcher. I'm flashing my SD card. I'm introducing. So as I told you, Etcher, it's really simple. You just need to select the operating system image, the SD card, or whatever you want to flash the SD card, and click flash, and it works. So actually, it's pretty well used in everywhere to install Ubuntu's, Raspbians, etc. on a lot of systems. Okay, so we are doing this right now. Still 1 minute. What else? What else I'm forgetting? Okay, so what devices are compatible here? I mentioned at the beginning that Balena, so that Raspberry Pi 3B Plus, it's running. So we need 64 bits processor. So all of these Rosetta Home and Full for COVID works or jobs are very CPU intensive. So it's just using CPU. It's not GPU. Okay, so the flash is completed. So sorry, give me a sec. Okay. So let's have fingers crossed that it's gonna work. Okay, so I just plug the Raspberry Pi again, and I leave it here next to me. And if everything goes well, automatically it will appear here on the dashboard. Okay. So when it will be handshake with my router. And then, just power it up the Balena OS. It will appear here, and then we will get inside, and you will see all the process to download the containers, supervisors, etc. But I was explaining. So what devices are compatible? So it's very CPU intensive. The Rosetta Home, no GPU actually. We see. Well, we have a wild voice. Nice name. So it's connecting right now. So Raspberry Pi 3 B Plus, I think it's 64 bits, but it's 1 GB of RAM. And Raspberry Pi 4, I think there is 1 GB, 2 GB, and 8 GB of RAM. Well, let's get here inside to see what's happening. Okay, it's already updating so it's downloading all the containers. Okay, so it's pretty interesting that it's running so fast right now. Cool. Let me get, sorry. Let me get here. Okay, so it's downloading the images, downloading the containers. One thing that it's important now is that we will need to push here public device URL. Okay, that means that my URL will be public. Well, will be public with a Balena cloud URL that I can share with you if you want to see my data. But I also have this IP, my local IP address available for me. I was mentioning, okay, so I think my Raspberry Pi, it's 4 GB of RAM. I have another one of 8 GB of RAM that it's unplugged right now. So most of the jobs are very big on size and are very intensive. So usually they work really good on 4 GB or 8 GB of RAM, not on 1 GB of RAM. The researchers at Baker Laboratory on the University of Washington, they do special jobs for the boards of 1 GB of RAM. So sometimes if you're going to use a 1 GB board, sometimes your device is waiting for a new job because the queue of small jobs is over. But it's, just leave it there, and once there will be a new job of 1 GB, it's gonna be running. Okay, so we have the containers running, the UI and the Boeing client. The UI, it's what you are gonna see now, and I think it's downloading the first project. So let's click here. It's working. Cool. Finally, we made it work. So what's happening now? My Raspberry Pi, it's downloading the first jobs. Okay, at the moment it only downloads one job. Okay, so sometimes with the Raspberry Pi 3 or with 1 GB of RAM, what's happening is that it says here on the logs no jobs available, but that's not a problem. You just wait, be patient, and it will arrive. So actually, 4 new jobs are arriving, as you can see. So they are downloading. So we can see the state here. At some point, once they will be downloaded, they will be able to start running, and some will wait. I think up to 4 processes are being processed in parallel in a Raspberry Pi 4. In Raspberry Pi 3, I think with 1 GB, I think it's up to 1 job running in parallel. It's for the project Rosetta Home, and it's estimated 13 hours of work until usually it takes about 8 to 10 hours to do a job with these Raspberry Pis here. I mean, it's really cool. And then another thing that it's interesting is here on the right, there are some statistics. This is the Rosetta Home, the Fault for COVID team, what it's been crunching on the whole story. But then I have been crunching 0. But if in 13 hours, yes, I will have more than 0. So what else? So it was. So I leave this here till it's getting download. So it's so let's see if we can start folding some proteins to fight the COVID-19 while we speak. One thing that it's really interesting. So it was interesting when we launched the project into the community, that some people was complaining like, what are you gonna do with a Raspberry Pi CPU? No, maybe some of you are thinking about that. No, it's that's cheat. No, what can you do? No, with my computer I can do like tens of Raspberry Pis. Yeah, and that's true. That's true. But our goal was not about becoming the best crunching data company in the world, or not company, but project in the world. The goal was to get as many boards, so to as well involve IoT boards that we have on our tables that are unused. So involved all of them as well to help to fight the COVID-19. It was not about it's a tiny CPU or whatever. It was more about, okay, all together we can make it. No, and there are a lot of IoT boards there. So we had this type of complaints, no, that the Raspberry Pi couldn't make much, but the key is this massive adoption. No, we saw a lot of customers from Balena saying, "Hey, we have to ship next month these hundreds of Raspberry Pis. So before we ship it, we are gonna put them crunching data for folding data for the fall for COVID." So we found as well this very positive feedback, from people that that was super cool. And actually was the thing that we wanted, and this is what we have today. Actually, we have. Let me refresh these. Actually, so we have 6,105 devices crunching and folding proteins for scientists. Actually, let's go to Czech Republic. How many there are? My CPU it's getting crazy right now, but we should see more here, right? So let's as I show you, that's super simple, and it's about all together trying to bring just overboards, Raspberry Pis, and even spare computers. I think it's even a USB stick solution that you can put on your laptop, so you don't need to delete all the information from your laptop. And so we have as well forums and what else? Let me see here. We have forums if you have questions. We have the GitHub account. We have let me go to community. We have these forums. So actually, if you are using Balena as well, so the forums are very active, and you can find David and me answering, and the hardware hacker team and Balena team answering questions here. And what else? Some of these are running. We are already folding proteins for the scientists. Actually, that's really cool. So actually, there are 3 processes. 2 are waiting. So when 2 of these are gonna get done in 13 hours, the 2 that are waiting will start folding, and it will download more processes. What else? So actually, these complaints that we get at the beginning, it was kind of tricky. But the good part here is that, or the interesting part is that just with Raspberry Pis, the community that we could move, etc., we are actually that since a couple of weeks ago, we are the 1%. So we are crunching. We are on the top of 1% of companies crunching data daily data. For Rosetta Home, actually. So we have these 6,000 people. Some of them are, of course, not online anymore, but some of them are still crunching data. And we have this daily average of credits or crunched data that makes us to be the top 14 in the world. So that's pretty awesome, actually. So we are, even the Czech national team, it's below. So let's imagine how amazing it's this distributed computing, and how all the community together we can make sense, connecting things to the internet. And I think, that's all. What else? I think that's more or less all with no slides that I can tell. I'm open to questions. And other IoT questions if you have as well.
Yes, absolutely. So we have one question.
Sure.
Are there some exact numbers on how much can one Raspberry Pi help with calculations, like 10, hundreds, etc.?
Sure. So there is this. Let me check if I have another Raspberry Pi actually running on. Let me get into another. I have it in another screen. Give me a sec. If I can find it somewhere. Okay, so let me show you. So one thing, maybe, I don't know. I don't think you're gonna see anything, but actually every day I'm on my Raspberry Pi. So I have another Raspberry Pi here. Okay, it's hot. I can say it's hot. That it's, yeah, I have now 2. Okay. So this one has been on for maybe 1 month or so. So it has been crunching like 20,000 credits. So it's about 1,500 credits per day, what they call it, credits. So yeah, there are about, yeah. So it depends as well on the Raspberry Pi, etc. But that's my numbers. I don't know if someone else has a lot of numbers, but these are my numbers. So actually, one can make this. So we have like kind of thousands of Raspberry Pis crunching data in parallel right now. More questions?
Okay, we didn't have any more questions, but I'm sure that people would like to join you in the 3D world and go and ask you and video chat with you in person. In person. I would just maybe summarize where people are from our little poll. So apart from Czech Republic, obviously we have people from Finland, Slovakia, Romania, Switzerland, France, and the 3D world, as somebody said. So that's very nice. It's great to know that there are people from all over the world watching us. And I'm sure that if we were in an offline venue or a real venue, people would clap. Thank you for our talk. So please now go and join.
Is it possible to clap on the 3D world, or how does it work?
I don't think so actually, but like I can clap here at least.
Let's jump. I think it's kind of funny to jump. Let's change the claps for jumps.
So please go and join the 3D world. Go to the speakers corner, and everybody on the stream. Thank you for being patient with us. This is our first time being virtual conference. But Marc, thank you very much. Thank you for taking up on the challenge of having no slides in the end. But I think it was great.
No problem.
A live demo is always the best. So, and you were also on time. So thank you very much again. And for all of us, we will meet here again at 3 p.m. exactly.
One last thing,
Central
actually, Bara, if it's possible,
Yes.
one last thing. It's every Friday, 6 p.m. Central European time zone. We do IoT happy hour on YouTube at Balena, and we talk about any type of project. So you can go on the Balena YouTube channel, and we talk about IoT. So if you're interested in IoT, there is this IoT happy hour at 6 p.m. Central European time zone. It's really cool, and we do some fun stuff there. So feel free to go there and say hello as well.
That's great. Thank you very much for the invitation.
Welcome. So I'm going to jump into the 3D world in a sec.
Thank you very much. Bye for now.
All right. Thank you. Bye.